right, classwork on the board for you as we review over parabolas and circles. Got a couple of conics I want you to graph on a Cartesian plane. So get them into their easier form, go ahead and graph those. And then a couple equations I want you to get. I've given you the center and radius of a circle, find the equation in the conic form. I've also given you the vertex and the directrix line for a parabola, and find for me the equation of that parabola. Pause the video for a few minutes and work. My students in here took about a dozen minutes or so to complete the assignment. Obviously you can take as long or as short as you want, but pause the video, and when you resume, we'll take a look at these together. All right, so Jamie, on the first equation, first of all, what shape are we expecting to get here?
A parabola.
A parabola. We know that because?
Only one is squared.
Only one of them squared. Good. And with the parabola, the first thing we want to do
is move everything that's not the squares to the other side.
So
X squared plus 6x, leave a space, equals 8y plus 3.
There we go. And then we fill in the space with a? 9, but what we add to one side,
that's add to the other.
So I'll add that to the 3 as well and make that become a 12. All right, good. Quentin, we're off to a good start. Now what?
Turn the 8 squared into a binomial squared.
Right, turn the left-hand side into a binomial squared and we'll get?
X plus 3 squared.
And what do we do on the right-hand side?
Factor out 8.
Good. Even though you say, well, there's not an 8 common, it doesn't matter. You still have to pull out the 8. So what do we wind up with?
Y plus 4 halves, or 3 halves.
3 halves, there we go. Or 1.5 or 1.5, however we want to do it. So based on this, which axis is the axis of symmetry going to be, class?
Y.
And we knew that from the conic form, didn't we? We knew it was the y-axis. Where's the vertex of this particular parabola going to be? Class?
-3 halves.
Good, Jamie. -3, -3 halves. So we should go to -3, -1.5, and we're going to put a new y prime axis right here. What is the focal length on the y prime axis going to be, Jamie?
2.
+2, which means up 2, which puts us right here at the half, which means we're going to go down 2 to our directrix. And then the lattice rectum length, the whole lattice rectum, class, is
4.
Well, the whole thing is 8, so therefore each side is 4, which is usually what I ask. How long is each side of the lattice rectum? And so we'll go over 4 in each direction, and we'll get our parabola that curves up like this. How do we do on the first one?
I forgot to add 9 to the other side, or 12 to the other side.
Gotcha, so you still have the +3, so you have like 3/8.
Yeah.
Yeah, okay. All right.
I was confused on the last rectum. I had it being 4 total and the 2 each.
Okay, so remember, this value is 4p, and the lattice rectum equals the absolute value of 4p. Therefore, normally what we do is we say each side equals the absolute value of 2p. Well, p is the focal length. So when we say the focal length is 2, that means each half of the lattice rectum is double that, or 4, for a total of 8. Does that make sense?
Yeah.
All right, good. Questions on that first one? Let's take a look at the next one then. And what do we need to do here? Quentin, start us off this time.
It will be y squared minus 2y plus 4 equals -4x plus 9.
Right, same thing again. And that's the downside, I think, to being so smart that you complete the square, but because you completed it before you even finished moving stuff, you forget to copy it. Right? It happened last time, looks like it happened this time as well. And so we do end up with the y minus 1 squared, which I think you had. But here, instead of a 9, we should have had a 10. What do we end up having to factor out here, Jamie?
The -4.
The -4, and we pull it out, we end up with x
10/4.
minus 10/4, or
5 halves.
5 halves. Now you had minus 9/4, which again is really annoying. Fourths are obnoxious. Halves aren't as bad. I wasn't trying to make it that obnoxious, but again, that's maybe did I forget to add something? But hey, I'm glad you made the mistake now versus on a quiz or test, right? Because it gives you a chance to realize, ooh, this is a mistake I'm prone to making. Let me watch for that. Let me go back and check those things on future quizzes and tests. All right, so where is the vertex supposed to be in this particular problem, Jamie?
5 halves, 1.
Good. Remember, the parabola is the one where it could trip you up. The x is here, the y is here. So 5 halves, 1, or 2.5, 1. So we'll go over 2.5 and up 1. There's the vertex. Which axis is the axis of symmetry this time, class? The x, again, is the non-squared variable, so we'll lightly draw an x prime axis right here. And what is the focal length going to be, Quentin? -1. So we're going to go backward here to the focus, which means we go forward to the directrix. And if the focal length is 1, each side of the lattice rectum is double that, 2. Or you could say the whole thing is 4. That number is the length of the lattice rectum. So we'll go 2 on this side, 2 on this side, and a tighter parabola this time. Something like that is what we should have had for our second graph. How did we do on the second one? Obviously vertex was off. Otherwise, were we good?
Okay. I had a -9 instead of a positive when I moved it over.
Oh, so when you moved it over and you added 1, you had a -8, so you had +2 right here. Okay, so you were back to up 1. Okay, everything else good as far as lattice rectum and focal length, go in the correct direction. All right, questions at all on graphing parabolas? Again, just reviewing, making sure we don't forget some of these things as we progress through ellipses. For the next one, finding the equation of the circle given the center and radius. This really couldn't be easier because you have exactly what you need. You need 2 things, center and radius, and you've got them both. How do we start out a problem like this one here? Jamie?
We have x minus 3 squared plus y plus 2 squared equals 49.
Good. Start off by literally plugging it into the circle form, x minus x1 squared plus y minus y1 squared equals r squared. And then to go to the conic form, all we have to do is square the binomials, right? So we end up with?
And then y squared plus 4y plus 4.
All right, and then the 49 is going to come over to this side as a -49, which ends up giving us class A -36 equals 0. And there's the lazy man's way to do it right there. Again, you didn't have to necessarily try to do all those time-saving steps, but should have ended up with that answer, and did we? Excellent. The next one, we want the equation of the parabola. Now, the parabola is defined by a focus and directrix. Locus of points equidistant from a given point focus, given line directrix. But the equation does not include both focus and directrix. What does the equation of a parabola include? Vertex and focal length, right? It's x minus x1 squared equals 4p y minus y1, or, reverse the x and y's, right? That's the basic form. So what we wanted to do, remember, and this was that lesson that we recorded without you guys, on the green chalkboard, right? But we said what we want to do is start with a bit of a sketch. So I'm going to draw a little bit of a sketch. Hopefully you did also. And you said, well, if the vertex is at -4, 1, that'd be right about here. And the directrix line is y equals 3. Now, y equals 3, what does that look like? Anytime it's y equals blank.
Y is at 3.
Y is at 3, so the line is parallel to the x-axis. Remember, y equals is always parallel to the x-axis horizontal. So, when you come up to y equals 3, that's the directrix. That's the vertex. All right? If that's the vertex, how far is vertex from directrix line? It's at -4, 1, and y equals 3. So it's a 2 units away, right? Going up. Which means if we went 2 units down, I would get to the focus. All right, so -2 is my focal length. Well, I now have vertex, and focal length is -2. Therefore, the 4p is -8. The last thing we need to know is which axis is the axis of symmetry. Well, if this is the vertex and this is the focus, and not drawn to scale, obviously the axis of symmetry is the y-axis. So I do want this basic form where the y is the non-squared variable. So we should say x plus 4 squared equals, now the p was negative 2, so we already said that the 4p is the negative 8, and then y minus 1. But we wanted it in the conic form. So here I need to, and then here I just need to distribute. So when we square, we get? And then over here we distribute to get?
Negative 8y plus 8.
But we're going to move the negative 8y over as a, we're going to move the positive 8 over as a, and put that with the positive 4 to get a, all equal to 0, and there's our equation for the parabola. How do we do on that?
Shaky on it.
Shaky on it. Does it make sense now? All right. Questions on any of the classwork? All right, then let's get back to what we've been working on more recently, and that was our latest conic, class the ellipse. How is the ellipse defined? Again, I know the exact wording's hard, but you can still probably, I think, convey the idea. What is an ellipse, Quentin?
It's a locus of point.
It's a great way to start. Besides, it sounds cool.
That is
So does it have one major point it goes about?
It has 2 points.
Ah, 2 points. Okay, so what about those 2 points is true for the ellipse?
Sum of two distances is equal to
Itself.
Yeah.
Is constant. That sum of the distances from those 2 points is constant. Those 2 points, of course, class, are called the 2 points that are inside the ellipse, that constant, that sum of distances stays constant. The foci. Right, those 2 points called the foci. If we drew a line through the foci, then we would have the major axis of symmetry. Now, technically, the major axis's length doesn't run focus to focus. It runs end to end, vertex to vertex, right? Now, the very midpoint of the major axis is called the center of the ellipse, right? And if we drew the perpendicular through that center, or the perpendicular bisector, if you will, of the major axis, we have the minor axis. How do we represent the length of the major axis? Well, yeah, it's from VV prime, but algebraically we represent its length as equal to 2a. Remember, each half is a, and then the length of the minor axis, 2b. The focal length is represented by the letter c, but it's equal to square root of a squared minus b squared. We said if we wanted to compare focal length c to half major axis a, the ratio c to a gives us the eccentricity of the ellipse. Good. And an ellipse's eccentricity is always between 0 and 1. Technically, remember, there are a couple of directrices outside the ellipse. We don't even care about them. We don't even graph them because they don't really define the conic. So who cares about them? But we do graph a couple of focal chords that go through the foci. What are those focal chords called? Each one is a lattice rectum, so plural is latera recta. Latera recta. And what's the basic equation form for an ellipse if it's centered at 0, 0, Jamie?
Is it 4?
What's the basic form? The basic equation look? Question, helper?
A squared over a squared plus y squared over b squared equals 1.
And we said that's if it's centered at 0, 0. If it's not centered at 0, 0, Jamie, we tweak this just a little bit.
It's x minus x squared, and y minus y squared.
There we go. Now, a squared or b squared could have trade places, right? A squared's not always here, and b squared's not always there. They could be either. How do I know which of these two guys is actually the a squared?
The
one that's bigger. So if the bigger number is here, that's the a squared, that's the b squared. If the bigger number is here, that's the a squared, that's the b squared. All right, so you had just a couple problems to do for homework. Go ahead and have your homework out and books open to page 245. Page 245, you did number 1E and number 10A, and we'll take a look at those. See how we did. Let's zoom in just a little bit here. Graph that a little bit easier to see, hopefully. All right, so for 1E, again, the key to this form, class, is you've got to set the equation equal to 1. So on letter E, we had to divide everything by 64. That ended up giving you what for your elliptical form equation, Jamie?
S squared over 16 plus y squared over 64 equals 1.
There we go. And of course the center is the first thing that we'll find, but of course it's 0, 0 because there's nothing added or subtracted from the x and y as they're being squared. We needed to locate which axis is going to be the major axis. The one that's going to have vertices at the end, the one that's going to have foci on it. Which axis is major here and how do we know? Quentin?
Y-axis.
How do we know?
Yeah, it's a larger denominator.
It's got the bigger denominator. So how long is the major axis, Jamie?
16.
It's 16 units long. This is a squared, therefore a is 8. So the whole length is 16, 8 in each direction. So this is going to take up most of your Cartesian plane, right? The minor axis length. Jamie, how long? And, or to be Quentin, how long? 8 for each. Right, obviously, again, this is your b squared this time, so b is simply 4. 2b then makes it 8. What about the focal length, Jamie?
That's root of 48, which is 6.9.
There we go. We're going to take the square root of the a squared minus b squared. So that's square root of 48. And you know the square root of 49 is 7. So it's got to be pretty much 7, 6.9. Even if you hadn't pulled a calculator out, you'd kind of figure that. And then what about the half lateral recta lengths? What's the formula for that again, Quentin?
Is C over, no.
That's eccentricity, C over A. What about half lattice rectum?
2b squared over A?
That's the whole lattice rectum, so to cut it in half, just b squared over A. So if we just took b squared and put it over A, we'd get exactly 2, which that works out pretty nice. They're like nice, easy numbers. So I need to have a y-axis that at least goes 8 in each direction. My x-axis doesn't have to be quite as big, though if I want to do both of these on the same Cartesian plane, probably be good to have it ready for next problem anyway. So I'll go ahead and draw both axes a good size. Who just made it? Yeah, I'm making it there just fine. Okay, so my center rather is at 0, 0. On the y-axis, I'm going to go up and down 8. And I'm going to go out 4. And the focal length is 6.9, so almost to the 7 and almost to the negative 7. But from those points, we're going to go out exactly 2 in both directions. And as you graph, start at the vertex, and don't go straight lining here, but slowly curve until you're almost pretty much coming in straight here. And I kind of actually missed that that end of the lattice rectum there. That didn't exactly help. It's always good to use pencil. Yep, missed that as well. The bigger they are, the harder they draw. It's an old saying of mine. Just kidding. I think that was the bigger they are, the harder they fall. You ever heard that saying?
Mm-hmm.
Yeah. Some of the little guys say to pump themselves up before they get creamed by a big guy. Or something the little guy's friends say to pump up the little guy before they send him to go get creamed. The little guy's former friends tell the little guy before he goes to get creamed by the big guy. Not that Grace Christian School in any way advocates violence, fighting, bullying, or any such thing. Grace Christian School respects the rights and dignity of every individual, etc., etc. legal jargon, etc. All right. And so after much correction, it's probably still not perfect, but we get the idea. Did you have some big old ellipse like that? All right, I like smaller because they're easier to draw. All right, questions on 1E. All right, let's take a look at 10A now. And this one had a little bit more going on with, well, whatever. This one had a little bit more going on. We had initially 9x negative 1 squared plus y negative 2 squared equals 9. What do we have to do to get it equal to 1 here, class?
Divide by 9.
Divide everything by 9. When I divide away the 9 here, it's going to cancel, so I really end up, class, with a,
X minus 1 squared.
yeah, 1. Here I divide by the 9, there's nothing to cancel, it stays a 9, and of course that means at the end it all equals 1, if you're too lazy to rewrite it. So, where is the center this time, Jamie?
1, 2.
1, 2. Which axis is the major axis, Jamie?
The 1.
The y-axis once again, so we're going to have another vertical ellipse. How long is the major axis, Quentin? 6, or you could say 3 each. And how about the minor axis, Quentin? 2, or we could say 1 each. What about the focal length, Quentin?
Square root of 8.
Which is about
2.8.
2.8, right? We know square root of 9 is 3, so we know it's going to be a little smaller than that, but since the squares are closer together, not quite 2.9, but 2.8, and then that's if you're really into trying to figure things out and don't want to pull your calculator out, that's how to think it through. The half lattice rectum length ends up being what, Jamie?
1/3.
1/3. The b squared over a, which is 3, gives us a third. Of course, that's about 0.3, though I think the 1/3 is easy enough to estimate anyway. And so let me change to the green chalk here and maybe zoom in just a little more still. Hopefully it's not getting pixelized at this point, but I don't think so. All right, so our center's over 1 up 2. And I want to draw a new y prime axis very lightly through here. Supposedly it's a straight line, just not the way I draw it. We're going to go 3 each along this line that I drew to the vertices. We're going to go just a single unit out. So again, a very skinny ellipse. Eccentricity here, 2.8 over 3. And what is that on the calculator there? 2.8 over, it's got to be like 0.8, 0.9 something. It's going to be 0.9 something.
Yeah. 0.9
Yeah.
would be
0.93.
And eccentricity only goes up as far as 1. We're really close with how skinny this ellipse is. And then we're going to go 2.8, so we can see that the foci are almost to the vertices. And then we'll go 1/3 of a box over in each direction, which isn't much, which is good because we don't have a lot of room to curve till we hit here and here. There we go, and something like that, just a little bitty one that's offset because of the shifted center. How do we do on this? Any questions on this? All right, let's go and do 10B as we wrap up the hour then. Tomorrow we'll get into how to go from a full conic form to the elliptical form. We'll save that for tomorrow. Let's go and wrap up by doing 10B now. They're on page 245. Check your analysis, make sure we're good to go. Any questions at all? All right, go and graph, or continue graphing, I should say. And how do we do? All right, feel like we understand, once we've got it in this form, how to handle the ellipse. All right, there's going to be a little bit more algebra involved in getting the elliptical form from the conic form, but we'll save that for our next lesson. No homework this evening? Have a wonderful rest of your day. When the bell rings, you'll be dismissed.